After a fatty meal, the lipids form large emulsion droplets inside the GI tract. These emulsion droplets are acted upon by the bile salts plus the pancreatic enzymes. Pancreatic enzymes break down the lipids. The lipids we ingest consist of cholesterol esters, phospholipids, and triacylglycerols or TAG. The pancreatic lipase breaks the TAG into diacylglycerol and finally into the monoacylglycerol by removing two fatty acids. So, it forms MAG. Cholesterol esterase removes the fatty acid attached to the cholesterol, forming fatty acid and the cholesterol. When phospholipase A2 breaks down the phospholipid by removing the fatty acid. First it is converted to lysophospholipid and then the other fatty acid is also removed, converting it into glycerol phosphoryl base. Bile salts aid in emulsification and micelles are formed from the emulsion droplets. Micelles are 200 times smaller as compared to the emulsion droplets, and these contain the hydrolyzed lipids. These dock against the intestinal brush border cells and their contents are transferred into the enterocyte. Here they go to the endoplasmic reticulum where these are resynthesized. So, inside the endoplasmic reticulum these are resynthesized. MAG becomes TAG, cholesterol and fatty acid become the cholesterol ester again, and the phospholipid becomes the glycerol phospholipid base, and the free fatty acids transform into the phospholipid again. So, now these are increased in size and these cannot be transported out of the enterocyte as such. So, what happens is that microsomal transfer protein packs these lipids into ApoB48. ApoB48 is the apolipoprotein, and microsomal transfer proteins packs these into ApoB48, forming the chylomicrons. Now chylomicrons are big in size. These cannot diffuse out, so these are exocytosed into the lacteals. Lacteals form the thoracic duct, and from the thoracic duct these are released into the circulation as nascent chylomicrons. Here these encounter HTL, which offers ApoC2 and ApoE. ApoC2 acts as a spyware. It is the coenzyme for lipoprotein lipase, and as these are passing through the capillaries, lipoprotein lipase is dangling in the extracellular space in the capillaries surrounding the adipose tissue, the muscles and the heart. So, lipoprotein lipase hydrolyzes the TAG inside the nascent chylomicrons, and it hydrolyzes and sequesters it into the adipose tissue. So, here you can see that the TAG is sequestered into the adipose tissue. The fatty acids and glycerol resynthesize the TAG. Same happens in the exercising muscles. Lipoprotein lipase sequesters the hydrolyzed TAG, and that is resynthesized. And as for the heart muscle, it depends on fatty acid oxidation as the main source of energy. So, here also the lipids are sequestered inside the heart muscle. So, finally, the chylomicrons are transformed into chylomicron remnants as the lipid is taken out of these, and then the chylomicron remnants return the ApoC2 to the HTL, but still keep the ApoE. ApoE acts as the ligand for the receptors on the liver. So, these receptors capture the chylomicron remnants. The chylomicron remnants are endocytosed, form endosomes fused with lysosomes, and their contents are degraded. So that is the end of the chylomicrons. Important carry home point is that chylomicrons don't transform into VLDL or LDL. This is the end of the story for chylomicrons. Just some of the tag, if it is present after the chylomicron removal, that may be